Well, I'm recording the lesson for all the folks at home who are listening who are absent on the actual day of, right? Because they know when they're absent to watch the video in the shared folder, and then when they show up and say, "Hey," and they say, "What did I miss?" And I was like, "Did you watch the shared movie?" And they're like, "What movie?" Right? What video? And that's like a stab in my heart when I hear that. What movie? What video?
I was gonna retest and then just watch the
Yes.
video.
Yeah. Okay. Oh, there. Did you start already?
I didn't start it yet.
Oh, you had your name on it. Okay, there you go. Yep. All right. Bye, Garrett. And then Garrett, and then hi, Garrett, on the video. I'm saying hi to the Garrett that's watching the video right now. Yeah. Okay. Anyway, um, we're going to go through all this. This right here is just a list of things that we could do on the calculator. It would be boring for me to just start going through this. We're going to do this in the context of AIDS, right? Yeah, AIDS. So back when I was a seventh, sixth, and seventh grader, and AIDS was kind of taken off, it had everybody scared. Everybody thought it was a death sentence, and people didn't want to sit on public toilet seats anymore because you can get AIDS from toilet seats. And of course, we know now that you can live with AIDS. You can control it. It's a virus. It'll be with you forever, but you can control it down to like levels that are undetectable. So that's pretty cool how science can do that. Well, everyone who is a scientist probably had to sit through a class on linear and quadratic regression because they use it. They use it. Okay. So what we're going to do today is we're going to take a set of data or data, and we're going to create a graph of best fit to it, either a line or a quadratic. And then we're going to do a couple of things. We're going to use it to predict outside the data, which is called extrapolating, or we're going to use it to find values inside the data, which is called interpolating. Okay, so let's get back to AIDS here. It says, yeah, let's go. Let's go. We're not afraid of AIDS. Look at Magic Johnson, right? He was diagnosed in '92, and man, he's still living, and he looks fine. I think he got the drugs early. He had the money. Money talks. Find the quadratic regression equation and then predict the number of AIDS cases in 2006. Okay, so here's what we do. We grab a calculator. We turn our calculator on. And by turning your calculator on, I don't mean by saying, "Oh, baby." I mean by pressing the on button. Oh, yeah, baby. Okay. Now, I'm using this calculator here that everybody has access to, right? My fingers are not working. I hate that. There it is. So I'm going to reload a ROM file. Everyone has access to this. If you don't know where to get this, come see me. I'll walk you through it. It's under Corpy's World under Other Maths. There's two links there. All right, so I just loaded the ROM again, and I'm going to put it in this little window. Okay, so what we're going to do is put this data into a table, okay? And that table, you can find it by going to the Stat button. Now I have to take these glasses off. Sorry, I have to break the part because I can't see. Ah, yes, the Stat button. You'll see the Stat button right there. It's blinking at you. The Stat button. Yeah. So once you do that, we want to put data into the table. So we want to edit it. So click on Edit. Just hit Enter. And it takes you to some columns, L1, List 1, List 2, List 3. We're going to type in the data exactly as it appears given to us. We're going to let the inputs, the X values, be L1, and we're going to let the outputs, which is the cases, in L2. So you type in all of your X's first. So you just hit Enter. So type in 2000, 2, 1, 2, 3, Enter 2001, Enter 2002, Enter 2003. Enter, so on and so forth. Now you click to the right and you type in the cases, and this is where data entry can kind of get mind-numbing. You get kind of used to typing in certain numbers, and all of a sudden they all transpose on you, and you type them in incorrectly. It's very easy to say it was like 40,883 instead of 833. So be very careful. 41,289 and then 43,171. Now at this point you should have a dimensional match. Okay, we have 4 entries on the left and 4 entries on the right. If you ever get an error on your calculator that says error dimension mismatch, it's talking about the data as being longer in one column than in the other. Okay, because that'll cause some problems. All right, now all we got to do from this window right here is hit the stat button one more time. Stat. And we're going to go to calculate now. So click to the right. We're done editing. Now it's time to do stuff. Let's go to calculate. And it says to do a quadratic regression. So which number do you think is the quadratic regression? 5. Yeah. So all you got to do is type the number 5. You don't even have to scroll down to it and hit enter. You can just type 5. And now you got some choices here. The first one says, hey, is L1 where you have your X values? Because that's where I'm going to use for my X values. Is that what we want? Yeah. L2, is that what you want to call your Y values? Because that's what I'm going to use. Yeah. Okay, but I could change it there by hitting second 1, second 2, second. That gets the alpha L in there. All right, so frequency list, just say no thanks. Okay, no thanks. Pretend that that's a bad guy there offering you some candy here in town. You say no thanks, and you report him to the police. There was another lost life in the Hayes Independent District because of fentanyl pills that looked like Fruity Pebbles that people are passing out, and they're laced with deadly amounts of fentanyl. So say no to those pills. Anyway, we're back to AIDS. The store equation is the important one. So for store equation, you have to hit alpha trace. Alpha trace. And that takes you to your shortcut menu for your Y's, which is really the F4 menu. Let's go ahead and just select Y1, hit enter. Yeah, we'll enter it. And then you go down, enter, and it's on calculate. And you got to enjoy the suspense here. It's blinking, and it's asking you, calculate? No calculate. Calculate? No calculate. Calculate? No calculate. Right? Oh, suspenseful. What do we want to do? Let's calculate. Hit enter one more time. And boom, it throws this out at you. Throws this out at you. Uh-oh. It could be that I typed in some wrong numbers or you typed in some wrong numbers, which is super easy to do. Do y'all match my numbers? Yeah? Okay, 694. Okay. All right. That should be it. I think, Reed, you must have typed one of the cases in wrong, one of the Y values, because there's a lot to go there. 5 numbers. Now, let's go ahead and write down what we got here. It gives us the template. It's Y equals, A is 579. That's X squared. And then B is negative 2317120.2, and that's X. And then Y is going to be plus, look at this number, 231828169.4. If I wrote a song about that, you think it would catch on? Like if I said that was some girl's cell phone number and I sang it in a song? 231828169.4. Right? Someone could make that sound. I bet Willie Nelson could sing that and make that sound good. 231828169.4. That is the equation. That's it. Now, let's answer the question that follows up. Predict the number of AIDS cases for the year 2006. All right, so that's going to be Y of 2006. I don't have to plug it in manually. I can go straight to my graph and type in 2006, but where's my graph? I don't see it. If you hit graph or zoom 6, you don't see it. Here's what we're going to do. We're going to get the data involved. we are going to create a scatter plot. So to do a scatter plot, this is separate from what we're doing now. You're going to go to second y equals. That's both of those buttons are in the top left corner. Second y equals. And you're going to select enter. Let's just choose plot 1. By default, it's turned off. It's highlighted and off. All you got to do to highlight on is hit enter. Now, when you go down to type, it's going to have all kinds of different types. Histograms, box and whiskers with outliers. We just want the scatter plot, which is the first one and the default one. So you can just go down, toggle down to the next. X list is L1. Yep, that's right. List 2 is your Y. Yep, that's right. And then how do you want to mark it? Y'all get more options than I do. Apparently y'all can pick your own color. I'm going to mark mine with this simple looking thingy majigger, and y'all can mark yours with a really cool, colorful, something awesome thing. Whatever, show offs. Okay, now hit zoom at the top, and the number 9, which is for statistics. Woo! Look at that. Now that is something. When you got the data plots in there, you can do zoom stat, and it zooms in on a window that accommodates them automatically. It just so happens that our line of best fit is in that same window because that's exactly what we're doing. We're trying to get a graph that we can use. It looks something like this. You have points here, points here, points here. I want to get something, an equation that allows me to find what like a value like this is. What is this? Okay, what is this? I want to know what that point is, okay? This would be called interpolation. Interpolation. This is going to be within the data. Within the data. But it might be that this graph, which goes on forever and ever like this, would it be wise for me to use this equation for an x value out here? No, because now this is outside, right? This is outside the last data point, and it's just too far out there. It's too far out the data point. It's no use anymore. So when you're extrapolating, which is what this is called, we said that up above, extrapolation, you could say this is outside. You got to be careful when you're extrapolating, because you may end up with a number that makes no sense completely at all. So the closer you stay to the data points, the last data points on the end, the better. The better your approximation is going to be. But interpolation on the interior, for the most part, if you got good data, you can do that all day long. Till your heart's content. Interpolate. What are you doing today? Oh, I'm interpolating again. My heart is not content yet. Well, you have the right to do that. Extrapolation, be careful. All right. So here's what we're going to do. Go ahead and hit your window button and look at your X max. It only goes to 2003. I want to evaluate something at 2006. So let's go ahead and extend this out to like 2009. 2009. Swine flu. Swine 09. What a great year. And now hit graph. Oh, look at there. Now you got points. You could adjust your window at the top if you were so interested. It's getting up there pretty fast. So X max, maybe I put that at 60,000. It's kind of interesting that we can now tweak the window that was given to us by our zoom stat, our zoom 9. There we go. That looks a little better. All right, and that's just playing around. Now here's what I want to do. I want to evaluate it at 2006. So I already wrote Y of 2006. Now all I got to do is hit the trace button, and you got to be careful here. If you just type in 2006, it isn't going to work because look at the top. We are, yeah.
It's saying error window range.
Okay, because you're probably on the wrong thing. Let's see. If you hit 2006 when you hit trace, it's not going to work. Let's see if it works the other way. You got to toggle up or down, either one. We got two things graphed there. We got the points and we got the curve. When you toggle up or down, you jump back and forth between the two. we're going to be using the equation. So you got to make sure that you're toggled onto the equation. And it says at the top, and you get a confirmation. Now you can type in 2006, and it tells you that there it is. According to the model, using past data trends, there will be 55,416.6 cases. Okay. And you know what's kind of funny? If this data was real, we could look up 2006 right now and see how many cases were there. And we could compare it to the model. And then you can come back and judge whether the model was good or not. Okay? Cool. If only we had a way to look up things, you know, instead of having to take a field trip to the library.
I think what he's saying is when you put the SY next 6000 and you hit enter, it actually graph the distance.
Okay, let me see your calculator. Whoever, did you figure out the error?
Well, it's back to a screen where it shows the graph, but it doesn't look like yours.
Uh-oh. What do you have for your window? Hit zoom 9 one more time. Just hit zoom 9. Do you get this come up? Okay, good. So now all you got to do is go to your window, go to 2003, and put it to like something that's bigger than 6, like 2007. And then just hit graph again. Okay, now you can hit trace, and you can toggle back and forth from your points, or you can toggle up to the graph itself, and now you can follow along on the graph. So what you need to do is when you hit trace, it's going to always give you the points first. You got to toggle and make sure that you're on the equation at the top. And then you can just type in whatever you want, 2006, and you get this answer.
How do you start typing?
Oh, yeah, you just start typing, and it'll accept the value once you're in trace mode. Yeah, there's no prompt for it. And I don't know why they don't have a prompt, but you could type right over the numbers that are there. All right. Any questions on the calculator? Raise your hand. My back is hurting. That's why I'm sitting. I'm sorry. My back is hurting. I was riding my motorcycle all night just to get here. Yes. The curve is showing up. Did Zoom 9 work for you? Oh, yeah. You have the points in the right spot. You're just not getting the equation. Oh, I know why. It wasn't sent there. So when we do the stat, calculate, and we do the quadratic regression, which is number 5, enter, wherever it says to store the regression equation, we have to hit alpha trace and go to Y1. And now it's in there. There you go. Any other questions or comments before we move on? Yeah, y'all are way ahead of me. Go ahead and start typing in the data for the next one. You're not seeing the graph either. Okay, so here's why. When we went stat, calculate, number 5, it was L1, L2. We skipped that, but we need something there. That tells the calculator where to put your equation, store regression equation. So that's where we go alpha trace. We activate the F4 window, which is all your Y's, and we want number 1. So alpha trace, number 1, and then you can calculate same numbers, but now when you graph, it's in there. Yeah. Zoom out. You have to hit zoom 3. I don't know if that's what you're looking for. And yeah, that's the center of the zoom. So if you want to center around that point, so if it's in the center, you can just hit enter. Yeah. Yeah. Is that what you want?
Like them.
Like mine?
Yeah.
Oh. So hit zoom 9 again. Now hit trace. I typed it in manually. Hit window, go to your window. I know my X max is this part of the screen over here. It's only going to 2003. I want to evaluate 2006. So I put in 2007. Just type over it. Yeah. And then everything else I left the same. And hit graph again. There you go. So all we did is we looked a little bit further right. And now hit trace. Type in 2006. Oh, hit trace again. See how you went to we got a toggle. See how we're on the points? Toggle up or down. Now we're on if you press up or down, it takes you from the dots to the equation. Now we can type in 2006. There you go, hit enter. And there's your answer. Yeah, good. Yep, good. All right. Let's do the next one here. It says that this table gives you the conversions between Fahrenheit and Celsius. And we want to create an equation that gives us the Celsius as a function of the Fahrenheit degrees. So I'm going to go ahead and clear my calculator out. That's the first thing I'm going to do. I'm going to hit second plus sign, number 7, click to the left, all memory, number 2. Yep, it's cleared. Okay. So I can it's kind of like following the directions, but we want to reset everything. All right, and then I paused it. Now I need to type in the data. So if y'all are so kind to wait for me, I go to Stat, Edit, so I enter, and I put these values here: 32, 68 degrees Fahrenheit, 122 degrees Fahrenheit. Yikes! 158 degrees Fahrenheit. I hope these aren't actual temperatures at this point. That's crazy hot. And then 0, 20, 50, 70, 90. Okay. So whenever you type this in, this is always L1, this is always your X. This is L2, this is always your Y. And so you got to be careful because you want to make sure that it is a function of the other. And yes, you could do that. You could say that the Celsius temperature is a function of the current Fahrenheit temperature because there is a way to go back and forth. All right, so now it says to do a linear regression. So I'll show you how to do that. Once you have the data points in your table, you just hit Stat. And now we click to the right again to go to Calculate. And we're going to use number 4. That's linear regression. If you scroll down, there's another linear regression down here at 8 that has the coefficients flipped. Okay, and we don't want that one. We want the first one. So it's the first one, number 4. So you would have to manually want to choose number 8. That's why it's buried deep in the list. Like you would have to want to have the intention of doing that deliberately. And there's things called Taylor polynomials, where they're in increasing order. So some people may just prefer it, I guess. But we want descending order. That's standard form. So we go with number 1. So anyway, yeah. Oh, okay. Well, let's see. Are you in the right place, Stat? Yeah. And you click to the right on Calculate? Oh, you're in Edit. Yeah. Okay, yeah. Click to the right to go to Calculate. Yeah, everyone good? Okay. And now all you have to do is select number 4 from the keypad. You do not have to scroll down there and hit Enter, although you could. L1, that's what we have in our X's. That's good. L2, yep, that's good. Frequency list, we just say, nope, no thank you, and we move on. Now, if you weren't seeing your graph earlier, you were only seeing your dots, it's because you didn't store your equation. We want to store it. So we want to put it in Y1. It's open right now, might as well use it. And so alpha trace gets you there. Alpha trace gets you the shortcuts to all the Y's. Now, if you want it in Y2, you could do Y2. I'm going to leave Y1, so I'm just going to hit Enter. And then I'm going to hit Enter again. Now it's the blinking Calculate button. Are you ready? Are you ready? Are you ready? Yeah, I'm ready. Boom. There it is. And now we write our equation here. A is 0.555. That looks like a repeating decimal. And then minus 17.777. That also looks like a repeating decimal. So I bet we can convert those to fractions with the calculator. Okay, so that's y equals mx plus b. Now let's go turn our stat plot on. That's the second part. Go to second y equals, and hit enter on plot number 1. Turn it on. Boom, hit enter, and everything else should be good to go. You just need to turn that thing on. Now, notice this. If you're ever in y equals and you're trying to graph something and it doesn't work, look in the top. You see how plot 1 is highlighted? You can actually go up there to the top and hit enter on it, which turns it off. It unhighlights it. Okay? We want it back on. We want to graph them simultaneously. So that's just a nice place to see if there's plots on there. So now, with the plot on, we can hit zoom. Guess what? Zoom 9. And there's the line going through most of the data points. All right, so that worked. Now notice the x-axis, we have fat axis, don't we? See that? We have fat axis on the x-axis. If you want to fix that, go to your window, go down to scale, and just turn your scale from 1 to 0. That's all. It's just a preference thing. The x scale is how often it puts the tick mark. Now if you graph it, no fat axis. Right? It's just a cleaner look. That's up to you. Now what? Now what? Well, the whole purpose of getting this mathematical model, this equation, is so that we can use it, right? We're going to predict. We're going to go out and predict crazy things outside the data. We're going to extrapolate, or we're going to interpolate things inside that never happened but could have. It tells us what is the Celsius equivalent for a 98.6 Fahrenheit temperature. So Y of 98.6. Now, what's significant about 98.6, besides the fact that it probably is a cool rock and roll station? 98.6. 98.6. No nose? That's the normal average temperature of the human body. Like when a nurse takes your temperature or you take your temperature, you compare it to 98.6. If it's 100, you're running a fever. If it's like 90, you're like living in a freezer, I guess. You want to be anyway. We want to know what it is in Celsius in case we ever visit over the pond somewhere. So you can plug it in right here for x and calculate it, or go to your window. Does your x max include 98.6, or did we have to make it bigger this time? X max is 210. Yeah, it contains 98.6, so we don't have to like extend the x max to include the year. So we could just hit trace and wait. If we hit enter, it's not going to work. We got to toggle up or toggle down, either one. But you get confirmation in the top. See that? I'm on list 1 and list 2, and now I'm on the function. And now when you're on the function in trace mode, there's no prompt for it, but you literally just type over whatever's there, 98.6, and you hit enter, and you get 37 degrees Celsius. So there you go. Now you have a trivia question. What is the normal human body in degrees Celsius? What's the normal temperature of a human body in Celsius? You can say 37 degrees Celsius. And people are going to be like, well, how do you know that? And you're like, Corpy's class. That's right. How does it feel? Y'all like this? It's not that bad, right? There's a lot of keystrokes that I'm throwing at you. So it's really just about getting used to the keystrokes. We use the calculators like this quite a bit in pre-cal and especially in calculus, and it's real important that y'all who've never used them before get comfortable with them. Right? All right. How are we doing on time? 20 minutes? You want to do the next one on your own? Sure? You're going to do a quadratic equation again and then answer the question. So I'll let y'all do this one on your own. I'll go ahead and do mine real quietly in the background. If you have a question, raise your hand. Hi. Yeah.
How do you reset
Oh, yeah, let's reset. Let's review that one more time. Second plus sign, like diagonal all the way across the diagonal. And then just look at the bottom, reset, number 7. And then we want all. We don't want just RAM. We don't want just archive. We want it all. And then you just confirm with the 2. And you should get memory cleared. There you go. All right. Any other questions before we start? Y'all are doing the next one by yourself. I'm doing the next one by myself, and we're going to compare answers. Well, I hope I don't fat finger a number entering it in. I tend to do that.
That tells you what you're approaching. Oh, you have the wrong text. Yeah. Yeah. There might be one. Yeah, I'm sorry about that. You haven't seen that. This is the retest, right? Yeah, just do that one. It's the same one. Sorry about that. Good catch. All right, remember to get it to graph like this, you have to have your stat plot on, and then you just hit zoom 9. Zoom 9, zoom 9, zoom 9.
Stat plots on, zoom 9. It'll give you the best window for all your data points. And then from there, you can adjust it. You can make it wider by making your X max bigger or smaller. Adjust the Y values, Y max, Y min. We have one question to answer. Now, it says, what would the height of the ball be if it travels a distance of 80 meters? Is that as easy as just going d of 80? Is that what we were doing? Like we did previously? Well, what's our input? Our input is the distance. Our input is L1. That's the distance. And it's telling you what would the height be when the distance travels 80. So can we just plug that in? What the height of the bee travels distance. I guess so, right? Is 80 in our window? Go to my window and I get 73. Look what happens. Let's say we didn't check that. We hit the trace button, we toggle to the equation, and you type in an 80, and you're going to get invalid error. Because it says go to, it's because we're trying to evaluate 80. So we have to go back to our window, change the X max to like 90 or 100 or something like that, and then just hit enter again. Now 90 is in our window. And that's trace 90. Oops. I did it again. Trace toggle 90. You'll know you did it wrong because if you just hit trace 90, enter, it'll take you to the home screen. It's like, oops, I lost the game. I got shot up and now I got to start over. There it is. It's 5.684 meters.
You did 90 instead of 80.
Oh, yeah. Well, I'll change mine to 90. I did. I sure did. Yep. I'll change it. I'll do the right one. Oh, this is much higher. Sorry, I can't really see, even with these glasses. Now, let's talk about that 0 I have at the end there. I told y'all to go to 3 decimals. Do we have to report the third decimal if it's a 0? In this case, we do. If it's a terminating 0, like 1/2 is 0.5. You do not have to put 0.500, okay? Because those are just trailing zeros. This is not a trailing 0, right? There's a 619 and several other variable values of numbers that come after that. So it's part of the accuracy, so you would need to have it. So when in doubt, don't leave it out, remember. Don't leave it out. We do want units, though, and that would be meters. So there you go. When the ball travels a distance of 80 meters, the height of the ball is 13.960 meters. Was that interpolating or extrapolating? Which relation? Interpolating? That would be inside the data? Well, let's look. Our data on this one here, our data went from 7. Ooh, that's too dark. Our data went from 7 to 67. So yeah, that's our input. And if you compare 80 to that, so it's X. Yeah, we actually extrapolated outside the data. We went from 67 to 80. Is that fair? Oh, yeah, absolutely. Is that good? No one really knows exactly how far we can stray and still get like decent results. It's all kind of like you can look on it backwards and say it was good or it wasn't. Okay, let's see, 98.6. When I did this, let's just talk about this one. I'll just say extrapolation. And what about this one up here when we plugged in the 98.6? Yeah, because it would fall somewhere in here. Good. Now that one should be pretty good. Interpolate. That one's easy to remember because in, right? Y'all know that X means out, like exit. But in definitely means in, and it's in the word. So that's all I have for y'all for today. So if you want to clear your calculators one last time and gently nestle them into their cradle instead of cramming them in there, not that anyone here has done that, I would appreciate it. And we'll now release the red light to green light.